Today we start Unit 4. Unit 4 is about systems of equations, inequalities, linear programming. Okay? But we'll start little with just systems of equations. You covered systems of equations in Algebra 1, so this is not new to you. Okay? There's going to be several things we do in this unit that are new, but the basic premise behind everything is the same as you did in Algebra 1. Now, I know you remember every single thing you learned in Algebra 1, so that's why we're going back over this stuff, okay? So the first thing you need to know is, what does that even mean? What is a system of equations? Any guesses? What does this imply? Right? I mean, it's plural, right? So it implies more than one, doesn't it? Okay? So more than one equation. More than one equation altogether that has the same solution. Okay? So let's write a system. Using B for the cost of a burger, F for the cost of fries, N for the cost of nachos, and S for the cost of a soda, write equations for each statement below. 2 sodas and 3 burgers cost $18. Can you translate that for me from English into math?
Yes.
Do it. 2S
3B
plus 3B equals 18. Now, 2 of you said different things. Why did I write down what you said as opposed to what he said? It told us what to use. Okay? We can't just use random variables just because we've always used X and Y before. We're going to use X and Y now. If it tells us what to use, we got to use that. Okay? So what about the next one? 5S 6B equals 39. Now, is this hard? No? Okay, then keep going.
2B plus 2S.
Now I don't know what to do. Because the B's are right here. Do I have to line up my letters?
No.
Really?
Okay, then,
Why would you?
Why would I? Okay, well, I'll just write it how you say. 2B plus 2F 2S equals 18. And for the record, this is a little foreshadowing here. It does matter that you line up the variables. But I don't want to spoil it yet. Okay?
So 2S, 4S.
So what's here? Last one?
4S.
2N
Plus 3B
plus 3B.
plus 2F equals 38.
Okay? Any questions so far? Pretty straightforward, right? Are they all that easy? No, I'd be lying to you if I said they were. Okay? Did they get a whole lot harder than that? No, they don't. Okay? When used together, these form a blank of equations in which is a set of 2 or more equations with 2 or more unknowns. System. Yeah. Okay? All right, the next definition. The blank to a system lists the values that can be used for each variable to make the equations in the system true.
Solution. The system to the system.
The solution to the system. Okay? So, we're just talking in general still. I'm just trying to get you some information about systems of equations. Okay? This system right here. Now, how do you know that's a system? Because it's in a box? You don't know it's a system because it's in a box. Okay? They're not hardly ever going to be in boxes. What you're going to notice is there's going to be sometimes a bracket around all of the equations. When there's a bracket around all the equations, even if it doesn't say this is a system, you can assume that it is because that says this is a system of equations. These equations are related. Fair enough? Okay? So this particular example is called a 3x3 system of equations because it uses 3 variables and it has 3 equations.
Which one comes first? Like the
I don't know.
variables or the...
I don't know. Which of the following would be the solution to this system? I have 3 choices. How do I decide which one is the solution?
Plug it all
Plug it
in.
in.
Now, when you say plug it in, what do you mean?
Put X. Like
Put
negative
X in for
four
X and put Z in
negative
for
1
Z.
for Y. Z for 2. And then just go from
Okay.
Quite time consuming.
That's a
I
long
feel like
way,
there should
isn't
be a
it?
shorter way.
There's a lot of shortcuts for systems of equations.
Teachers, pardon the interruption. We need any student that is in an ag class to go to the auxiliary gym at this time. Thank you.
Well, the good news is I'm making a recording, right? Okay. I don't even know what I was saying. What was I saying?
There's a lot of easier ways.
There's a lot of shortcuts. Thank you. There's a lot of shortcuts in systems of equations. I will not show you any shortcuts until you understand what's going on. As soon as we understand what's going on, as soon as you can prove to me that you know what's going on, I'll show you all the shortcuts I know. Okay? But until you understand the math behind what's going on, I can't show you a shortcut if you don't understand what's going on. That would be unfair to you, and that would be unfair to me. Okay? And your future math teachers as well. Okay? So, what we have to do is substitute in the x, substitute in the y, substitute in the z. Now, if I was doing this problem all by myself with no students watching, I would jump right here. Why?
Because it's the shortest.
Yeah, it's the shortest, right? Negative 4 minus 2 is 4. Then it's not A. 9.5 minus 5.5. So is that the answer?
Not necessarily.
Okay, so check the last one. 5 minus 1 is 4. Okay, so at least I don't have 3 answer choices now. I just have 2, right? At least I've started there, haven't I? Okay, so now where would you go?
To the bottom one.
The bottom one? Okay. Negative 9.5 minus 0 plus, oh, I don't know that off the top of my head. Do you know? 15, 16.5? Negative 9.5 plus 16.5 is 4?
Three, 16.5.
So just to be honest, it's scaring me that you're thinking this long.
No, it's not.
Okay, it's not. All right, okay. Nobody said anything, so I just didn't know. Okay. Okay, so what do we know about B?
It's not true.
It's not true. It's not the answer. Can we automatically assume C is the answer?
Not really.
No, because there are systems with
No.
no solutions.
Oh, you're right.
Okay? Not only that, but it only gives us 3 options. They could all not be the answer, right? There could be an answer, it wouldn't be here. So let's check it. 10 minus 9, so 1. 1 minus 4 is negative 3. Yes, that works. Okay? We already know this one works, right? 5 minus 1 is 4. Negative 5 plus 6, so 1. 1 plus 3 is 4. True. So I know for sure that C is the answer, don't I?
Yep.
Okay? What about number 2? Any ideas?
A 2 by
This is a 2 by 2 system of equations. 2 variables and 2 equations. So which is the answer? Well, 30 minus 21 is 9. Yep, that works. That must be the answer. Wait, no. 3 equals 7.5 minus 3. No, not the answer after all. 16 minus 7 is 9. 1 equals 4 minus 3. Wait, is that the answer?
We still have to see.
Okay, so maybe. All right. 4 plus 14 is 9. No, right? 4 plus 14 is not 9. That's not right. Oh, look. It is. But, guys, here's the question for you. If it works in both of them, isn't the answer?
Yeah.
Yes.
But you can have more than one.
Can you? Can you have more than one answer? That's a good question. If I graph these two lines, because wouldn't they be lines? If I graph the two lines, can you draw two lines for me that meet in more than one place? How? This is not a line. That's a line in a parabola, right? Yeah, they meet in two places, but both of these are lines, aren't they?
I've seen that.
Okay. Is there any possibility you can have more than one solution? Yes. Here's one line. Here's the other line. Okay. How many solutions do I have then? All of them, right? All the points on the line are solutions. Now, can we talk real fast? Is the answer all real solutions? No. What's the answer? All of the points on the line, right? Because the point right here, that's not a solution, is it? It's only, I mean, it's all the points on the line, and that's a lot of them, right? And an infinite number of points, but it's not every point. Fair enough? Okay. All right, so look at number 3. How is 3 and 4 different than the two we just did? They are not. Okay, they're not just different from the ones we just did. Anybody have an answer for 3 or 4? Or should we just save those as a surprise for later? Okay. The one thing we do need to talk about, let's go back to our beautiful pictures on the back. Okay. Where do these two lines cross? What is that thing called right there?
Oh my gosh, what?
There's like 80 things it's called, right? Point of intersection,
Okay,
a
that's
point. But I'm looking for one specific name that this is called. It is a point. What's another name for a point? What's another name for a coordinate? Ordered pair, right? Ordered pair. Okay? Now I'm going to try to do something that may or may not be successful. I don't care. I think you'll get the idea. Thank you. This would be like an x-axis and a y-axis, right? Okay? But what if we had an x-axis here and a y-axis, but I had a 3x3 system like this. So I had an x, a y, and a z. Can I graph that? Yeah, I got an x-axis and a y-axis. You see those, right? Guess where the z-axis is? Right there. It's coming out of the paper toward you. So it is three-dimensional. Okay? Now, can you see the 3 dimensions? Here's the z-axis. See how it's coming out of the paper? So if I'm going to plot the point 2, 1, 3, I would go over 2, because it's alphabetical, right? X, Y, Z. I would go over 2, up 1, and then out 3. Did you see it happen? Over 2, up 1, and then out 3. Crazy, huh? All of that being said, I have to know what that is called. If this, maybe that's 2, 5, if that's called an ordered pair, what is this called?
A triple.
An ordered triple. Okay. Did you notice how I steered your attention away from number 4? Because it actually tells you the answer right there. Okay, good. Okay. Ordered pair, ordered triple. Oh, I didn't even write it that way. These are ordered triples right here. And yes, it goes X, Y, Z in alphabetical order. Okay? Any questions about that?
When you use the third number to go out, you just go diagonally.
Yeah.
And then-
I just went along the Z-axis. See how I went along the Z-axis this way? I can't plot it for you in actual life because I can't go 2 here and 1 here and 3 up. I mean, that would be like, see how far away I am from the paper, 3 away from the paper? I can't really draw that for you. I mean, we have a 3-dimensional printer now, so maybe we can draw it that way. Not really. Okay? But you got the idea, yes?
Yes, ma'am.
Okay. So, the other paper that you have, I'll put this one, whoa, not that way. I'll put this one back up in just a second for those of you who didn't finish everything, okay? This is your homework paper right here, okay? Evaluate each equation for the given values in the ordered triple. If the values check in the equation, if they work, then shade in the box. When all the items are complete, the remaining boxes which have not been shaded will spell out a quote. Be sure to check each solution set for each equation. The equation will have more than one set that works. Okay? For example, let's start right here. Does this point work in this first equation? Let's see, -6 plus 6, which is 0. So -3 equals 14. Is that true? No. So I don't color that in. It's not true. I don't color it in. Got it? Now let's try for this second equation here. -2, negative. Okay, that's 4. 4 plus 6 is 10. 10. Wait, what did I say?
Why is that 6?
I don't know.
10.
How about 3? 4 plus 3 is 7. Is that better? 7 plus 15 is 22. Oh, that does work. So I do shade it in. Okay? Please don't get all OCD on me right now. You can do that later if you want. Just kind of shade it in so you know not to worry about it. Okay? Then you'll try this point in this equation. Then you'll try this point in the first equation, and second equation, and third equation. If it works, shade it. If it doesn't work, don't shade it. When you get all the way done, it wants to know what the solution is. How are you going to know which one's the solution to this system right here?
The whole shaded in. The whole.
Like the whole column is shaded in, right? Okay. Then at the very last part, take the remaining letters from left to right and put them in the blanks, and it forms a quote. Okay? Any questions about that? You got it? All right. Peace.